All right, so let's get started. Good evening, everyone, and welcome to the October meetup. My name is Damien, and I'm one of the hosts for the meetup. With me today is Himansu Patel, who is also going to present. He's going to be the main speaker for today. Before we get started, I will introduce the meetup as usual, and then I will give you a kind of a high-level overview of what we do in this meetup, just to make sure we're all on the same page. And then after that, I'll pass the microphone to Himansu, who is going to be the main speaker. All right, so nice to see all of you, and I hope you are all keeping safe as usual. All right, so Kubernetes and CloudNative Node Dialers, we are all about Kubernetes and the ecosystem. And we are part of a larger group called the CNCF meetup. So I'm going to go to the website for CNCF to show you. So this website here is called the cncf.io, and CNCF means Cloud Native Computing Foundation. Basically, this is the body that is responsible for Kubernetes. So it's a foundation for ensuring that Kubernetes and the ecosystem are all operational. So if you wanted to write a microservice, this will be a place for you to go and look for information. Okay, so like I said, our meetup is part of a much larger group, and I'm going to show you some of the other larger groups. So on the slide, on the screen, if you go down here, you see that literally we're all over the world. In fact, if you do a search for your city here, you might see that there's one running your city. And then if you come down here, also you see in North America, see the list of meetups that we have. So we're part of a much larger group in this meetup. And basically everything we talk about, like I said, is the Kubernetes and the ecosystem. And when we talk about the ecosystem, I'll take you to this slide here called the CNCF landscape. In the CNCF landscape, you have all the software that the CNCF manages. And apart from the one that manages, there are so many in the ecosystem, as you can see here. So in this landscape, you see that we have different categories. We have the database, we have the streaming and messaging, we have application definition and image build, we have continuous integration and delivery. And Himansu will be talking about ArgoCD, which is right here, right on this continuous integration and delivery. Okay, you move down here, you have under scheduling and orchestration, you have Kubernetes. Under coordination and services, service discovery, we have core DNS, on and on. So the ecosystem is huge. And in our meetup, we can talk on any of these topics. It just depends on what someone wants to talk about. All right, so that is kind of where we are as far as the meetup is concerned. And then let's go through some of the sponsors. All right, so you already introduced myself. We also have another sponsor called Brent. He's not here today. And then we have Himansu, who is going to be the main speaker for today. All right, so I'm from Cloud Technology Experts, and basically we do training. We are developing some boot camps in DevOps, Cloud Engineer, and Microservices. If those are some of the areas you want to focus on, take a look and see if those are of any relevance to you. All right, so for the announcement, the next meetup is going to be on November 18th. We are always looking for people that will share their knowledge on what they are working on. That is how the meetup runs. It's all a community project that people come here to share their knowledge, as Himansu is going to be doing for us tonight. All right, so that is about the meetup. Now I will give you a kind of a high-level overview of microservices, Kubernetes, Docker, just to ensure that we're all on the same page, because as I always say, most of the people that attend the meetups tend to be new people. And for the new people, some of them don't know what Docker is, or they don't have a clear idea of what Kubernetes is. So I'll basically try to give you a kind of a high-level overview of what these services are, so that when Himansu starts talking, hopefully you are going to understand what he's talking about. All right, so I'll do that briefly, just a couple of minutes, and I'm done. So here, I'm going to start off with this diagram here, just to explain and talk about microservices. So everything around Kubernetes is on the ecosystem of microservices. And microservices applications, these are new applications when deployed in a cloud environment. As you may know, a lot of organizations are moving from on-premise to the cloud. Now, when they move the applications from on-premise to the cloud, often that application doesn't scale very well. And a lot of companies have experienced this, including Netflix, eBay, and the rest of them. So when they migrate the application from on-premise to the cloud environment, it doesn't scale well and it doesn't fit well within the cloud architecture. And so those applications, when they deploy them in on-prem, they are usually called monolith applications. They are monolith. And if you look at what I have here on the screen, basically a monolith application, so let's look at this. So in this diagram here, we have, okay, this green hexagon here. This is the core of this application. So this application is like a share, it's a ride share like Uber or Lyft, okay? So in this application, you are going to have the passenger management, you're going to have the billing module, notification, payments, driver management, trip management, and all this, okay? And then you're going to have around it all the components that are useful for making sure that this microservice, this monolith application is usable by the users. For example, here you're going to have an interface for the users to be able to, use their mobile device, use their web, use their desktop and stuff like that. All sorts of devices. You are going to be able to make sure that the application works with them. Then if the users want to make payment, you also have a component here that handles the payment. If they want to send email, they can use SendGrid. If they want to communicate with text messages, they can connect to Twilio and all that. And also, of course, you need to have a database. And so the database has to have a connection. But this is the core of the application. This is the business logic, all right? And as you can see here, even though each one of these business logic is a different module, when it comes to deploying this monolith application on a platform like Java, if this application were written with Java, it's common to deploy this application as a WAR file. All these components, even though they are all individual modules, will be combined into a single WAR file, then sent to an application server like Tomcat. And then this application will be running from here. And then, so as you can see, all the application is basically running on a single node. If you wanted to scale this application, you probably have to now deploy the same application on another server. If you want to scale to like 5 nodes, you have to have 5 computers, all of them running this same application. So that is basically what a monolith application looks like. Now let's contrast that with a microservice application. Here's an architecture of a microservice application, which is pretty much the same as the previous one, but you can see now that we have a lot of differences. In the monolith, each one of these components, like the passenger, the driver, the driver management, the trip management, notification, payments, billing, each one of these are developed as a suite of separate applications. Each one of them is autonomous. So basically, what we have here, the business logic here is split into different components, all right? Each one of them represent like a complete separate API on its own. Some of these APIs are needed by some of the other components within the application. Some other ones may be needed to be used directly by the customers, as the case might be, okay? But most importantly, each one of these applications is deployed separately. So unlike here, unlike the monolith where you deploy the whole application onto the same server, here, each one is deployed onto a separate environment, maybe a separate virtual machine or a separate container. And this is where the concept of Docker and Kubernetes comes in. Because when you want to deploy this application, typically you want to make sure that each one of these applications is packaged in a separate container. And so you need, for example, here we have 1, 2, 3, 4, 5, 6, 7, 8. For the 8 microservices seen here on the screen, you will need like 8 containers to run them. You could scale them, okay? You could scale them, you can provide replicas on and on. So at the end of the day, you're going to end up with so many containers, all of them managed with, by Docker, okay? So this is where Docker and Kubernetes comes in. So these are normally the steps you want to take when you're trying to deploy your microservice. You've written the code, the microservice code. Then you use Docker to package the code along with all the dependencies, okay, in a single image. And then you typically send that image to a repository, a Docker repo, okay, so or a registry. So a Docker registry will contain all the images. And you are going to do that for all the microservices. If you have 8 microservices, you are going to follow the same procedure to make sure that all the applications are properly deployed or have their own images. All right. Then upload all of them to Docker registry. And then usually that is where Docker ends. Okay. To run these microservices, all of them together as a single application, you are going to need something to help you coordinate the applications. And this is where the orchestrator comes in. The orchestrator is the one that is going to help you manage all this suite of microservices. So Kubernetes comes in. These days, when you talk about an orchestrator, a container orchestrator, almost Kubernetes is the de facto, okay? So we can say it's synonymous. I can say a container orchestrator, or I can say Kubernetes, because pretty much Kubernetes is the one that is used for doing that these days. All right. So that is where Docker and Kubernetes comes in to help with the management of this microservice application. But once you start running your microservices application, there are a whole lot of other stuff you may want to do, like continuous integration and continuous deployment. And this is where the job of DevOps comes in, using the CI/CD pipelines and all the other ecosystems that you may need. Also, for the microservices, you may want to do some monitoring, you may want to do some logging, you may want to do some load balancing, service discovery, on and on. So for all these, you can either do everything within Kubernetes, or you can go to the landscape that I showed you earlier and look for the appropriate application that could help you carry out that part of the feature that you want to add. And like I said earlier, like today, Himanshu will be talking about ArgoCD, which is one of the components that you can use to manage your application. Okay, so why Docker containers? I already said that your applications are packaged into a Docker container. So Docker is an environment that helps you create these containers. And then Docker will download the images from Docker registries, and then it will help you to run this microservices application under the hood. You could use virtual machines like EC2 instances if you're familiar with AWS, but the default platform is always containers, because containers they are portable. You can move them to different platforms. They are very fast, and hence, well, they are very lightweight, and hence they are very fast. And also they are cheap. And people like things that are cheap, that work very well. So everyone loves Docker because Docker does a very good job. And then also why Kubernetes, I already mentioned why we need it, but here are some of the features that the orchestrator will give you. It will help you with scheduling of your microservices to the different containers. It will help you with communication between the microservices on different nodes. It will help you with the scaling. It will help you with security, monitoring, logging, networking setup, volume management. So really, what Kubernetes does is huge. Without that, like I mentioned earlier, it's almost impossible to run your microservices applications. All right, so that would be a quick high-level overview of Docker and Kubernetes and microservices, which is the core of what we do in this meetup. So now I'm going to pass you over to Himanshu, who will give you the presentation for ArgoCD and TektonCD. All right, so Himanshu, Let me try to pass you the ball, and then you can take it from there. So I need to make you the presenter, right? Or can you share? If I stop sharing, can you?
Yes, I think if you stop sharing, right. Damien.
I've stopped sharing now.
And you need to probably add my screen share to presenter view.
All right, I already added.
Okay, there we go. All right, that's good. All right. So thank you so much, Damien, for the wonderful introduction and details on the basic concepts around Kubernetes and containers. I think that will be very useful for the second segment of this session that I'm going to cover. And thank you everyone for joining with us today on this event. I hope this topic is going to give you some information and some takeaways, and hopefully you all would like it. So I'm not going to go through the basic concepts again, as Damien already covered. So we're basically going to go right in. I would just quickly step through the slides and get to the point. I'm going to cover automated deployments in Kubernetes cluster or ecosystem. How could you really automate the deployments? As we all know that Kubernetes clusters are meant for orchestrating the containers, which are essentially running microservices, and they might be a big volume of microservices, managing them all by hand, doing releases, deployments, and updates to the manifest by hand is definitely error prone and also very inefficient. To automate that process, definitely we need to rely on continuous delivery, the tool or the platform that provides ability to do the continuous delivery, and that's what we're going to talk about today. So cloud native concepts, Damien already mentioned microservices. I'm not going to go into the detail. Second thing is containers, that also Damien covered. So I'm just going to get just through it, but there are a couple of things that I wanted to add to what Damien said. Containers basically provides an ability to package your applications binary end to end. So applications, your applications dependencies end to end, which basically helps you eliminate environment variability. And that gives you a tremendous stability and consistency of deployments across the environments. So certain problems you might have seen that your code changes worked in one environment, but did not work in other environment. Those problems are hardly related to code. They are mostly because your environment, like operating system, libraries, packages, your runtime like JDK, your file system changes which are needed, they are all managed by hand or via some ad hoc process from one environment to other environment, or from one VM to other VM within the same environment. And that's the reason why you see the same application code deployed in one environment works, while it just doesn't work on the other environment. Containers eliminate this problem nicely by packaging the entire application dependencies as a one single container image, and that goes to your image artifactory, and that image basically is a shippable container which gets deployed from environment to environment and helps you get a very consistent deployment experience. Another advantage of that of the containerization is to be able to actually get build once, run anywhere guarantee. So image is actually built just once, that encapsulates end-to-end application dependencies, and then that image is deployed in development or lower environment Kubernetes cluster. If it works there, guaranteed it's going to work in your higher environments as well. So that build once, run anywhere guarantee helps you avoid building your code over and over again for distinct environments. Also, since containerization helps you encapsulate or package end-to-end application dependencies, it is very easy and organic to accomplish canary or blue-green deployments, you would be able to actually run multiple application versions in the same environment if you want to. If you want to accomplish controlled rollouts, you can actually deploy newer versions of your applications only for the certain segment of market or only few users, and make sure that it works nicely before you actually increase your new code changes rollout to the wider segment of users. That basically helps you accomplish canary and blue-green deployments. If you wanted to do this with the traditional deployment way without container, it's kind of a big problem because your application binary contains only application code, while rest of the environment variability exists from VM to VM and environment to environment, and that would not let you accomplish canary and blue-green very easily. You can definitely do that, but it'll be a much longer and tedious path. Another thing is, of course, you can scale out your containers very easily as they carry the entire end-to-end dependencies within the shippable container image. The boot up of your application is very, very fast, as well as your scaling is nothing but just multiplying the instances or replicas of your pods within your deployment manifest, and that'll basically give you more instances for parallel processing. That's another advantage. Kubernetes is the platform that helps you orchestrate containers. If you have to manage containers by yourself, it is very hard, and it's kind of very cumbersome, because containers don't really leave alone. They need a lot of other network system and resources to be able to actually run, right? You can build containers. Sorry, guys. So you can build containers using Docker, right? And you can run containers using Docker runtime, but that is not very efficient, as you need to worry about a lot of other infrastructural details to be able to run, scale, and maintain operations of containers in your environments. So basically, Kubernetes is the platform. It's actually an orchestration platform that helps you orchestrate your containers. Damien, I think you'll have to go on a mute. If you're not, I'm sorry. Okay, so basically Kubernetes, in the world of Kubernetes, everything is a resource, and resources managed or defined as a manifest in YAML format, right? And as you can see on the screen, there are so many different types of Kubernetes resources. Depending upon your needs, you actually put your hands on those and you create the YAML manifests for them. And then those YAML manifests are used by Kubernetes to create the resource in the Kubernetes cluster, right? So there are some of the common Kubernetes resources are services, pods, deployments, ingress, replica sets, config maps, secrets. Those are some of the basic resources which you would need to be able to actually do any work in Kubernetes environment. These resources are all managed in a YAML format. You'll have to actually define them. And the YAML format looks something like this. If you can see here, there is a front-end service that is exposed for the 3 different pods or containers running for the front-end application. So these three front-end applications are nothing but just the one application with 3 instances running, right? And if you see, these are 2 different types of Kubernetes resources. One is actually pod, and the other one is a service. If you look at the YAMLs here, the first one is a deployment which lets you actually define how many replicas you want to run for the image of type image of your pod, right? So here we are using just like, as an example, the image is actually Nginx 113.1. We want to run the 3 replicas of it. So your deployment YAML is a resource for Kubernetes. When you create that deployment on Kubernetes cluster, it's going to actually give you that out-of-box guarantee that at any point of time, you'll have 3 instances of this image or this container running in the cluster. If for some reason one image or one pod dies or crashes, Kubernetes immediately honors that desired state deployment guarantee and brings up another one to suffice that 3 replicas. So that's all internal. If you want to accomplish something like this in traditional world, it's kind of very hard. It requires a lot of manual effort. But in case of Kubernetes, all of this is actually managed for you out of box, right? And this pods are exposed to the world outside by the service, which is the second YAML, as you can see here. It's of a kind service, and all you're doing is you're basically exposing that service on port 80. Right. So anybody who wants to access this pods will have to actually go through this service, and the service will then direct you to one of the pods depending upon the load balancing. I hope this helps. This basically gives you a very simple idea on the Kubernetes manifests and YAMLs. If you see here, these manifests are YAML files, and they are basically used by deployer, which is what this session is focused on. Deployer is something that is basically your continuous delivery tool, right? It makes sure that your YAML manifests are synced with your Kubernetes cluster. Right, so that is what the deployer actually does, and deployer basically integrates your manifest defined and stored in your Git repository with your Kubernetes cluster. Right, Kubernetes itself makes sure that those resources are guaranteed when you are actually creating them under the cluster. Right. I'm not going into much details here, as we're going to go look at the deployer, which is ArgoCD, just in a little bit. Another aspect of CloudNative is DevOps. We all know that DevOps is a culture which emphasizes mostly on people, processes, and tools. And in a nutshell, it's nothing but the collection of practices and principles, right? Mostly focused around continuous business planning, testing, releases, deployment, monitoring, and collaboration, tight collaboration, and information flow between customers, business, and development. Right now, here one thing that is being insisted the most is continuous delivery, continuous deployment. Right, and that is what we need to focus. If you really want to get the operations efficiency, you need to make sure that you have the continuous delivery, automated releases in place for your containers that actually simplifies your operations heavily. And that's not the only aspect. There are a variety of other aspects in the operations, but today we're going to focus only on the continuous delivery. So continuous delivery is the process of making the code change available to users so that the user can use it in the most efficient way, right? But that journey from code commit to the production deployment is not that simple. It requires a lot of aspects. It requires a lot of different things that needs to happen in a tight sequence, and all of them have to succeed to be able to actually see your changes deployed in production, right? And these are the simple concepts. You probably know this, so I'm going to skip over it. But continuous delivery is something that we would like to look at today with the help of ArgoCD. So in the world of Kubernetes, your ideal continuous delivery pipeline would be when the code is committed by a developer on the repository. The continuous integration tool, something like Jenkins or Travis or Circle or even TektonCD, they will basically, they will continuously have the trigger setup to listen to the events of code push, right? As soon as the code is pushed, code changes are pushed, they'll actually kick off the build. That build will do unit testing, code building, packaging, building the image and then packaging it and then pushing it to image repository, right? Once that is done, the continuous deployment part is actually continuous delivery part is done, where you actually built out an image off of your code changes and deploy and basically deployed it to your image artifactory, right? But that's not enough. That's not really going to give you the code changes in your environment. You actually need to now update your Kubernetes deployment to reflect that new image, right? So that's the second part. That's the second part of the continuous delivery pipeline, where the similar changes will have to be made on your pod manifest, right? So that pod or deployment manifest will have to actually change or increment your image version. As soon as that is done on your Git repo, your CD tool, you can use variety of CD tools. There are many CI and CD tools available, open source and commercial, right? But in the context of this session, ArgoCD is a pretty popular CD tool. It's pretty cool, and we're going to look at that just in a bit. ArgoCD will basically, listen to that event that the manifest of deployment has changed, new image has actually came. It'll immediately sync up that manifest with the Kubernetes cluster, which means the existing pods running are going to be killed, and newer pods are going to come up with the newer image, right? So ArgoCD actually makes sure that your code changes are delivered to the Kubernetes cluster as soon as your YAML manifest of the deployment is changed to upgrade the image. So that's a pipeline. Today, we're not really going to focus on Tekton, as I really want to cover a good amount of details on ArgoCD. So we're going to actually look at only the bottom part. But in a real world, what really happens is this, which is basically called fully automated continuous deployment. When the code is committed by developer on the source repo, TektonCD will basically trigger the job which builds your container image, and that gets pushed to your image artifactory. After that build is done, TektonCD will have a second stage which will update the Git repo again for the YAML manifest to upgrade the image version. Once TektonCD has done that, there is an ArgoCD sitting right there listening to the push events on manifests. As soon as that image version is upgraded on deployment manifest, ArgoCD will pick it up and it will actually deploy it to your desired environment, right? So this is actually the end-to-end pipeline. Maybe some other time we'll look at that, but today our focus is going to be, update this Git repo with the manifest and see how ArgoCD actually syncs it up to your Kubernetes cluster. If you guys have any question in between, feel free to put the comments on YouTube. Damien will actually, let me know, and we can cover those. So coming to now ArgoCD. ArgoCD is an open source continuous delivery tool or a platform developed by Intuit, and it's it has gained tremendous amount of popularity lately because the simple and easy installation, maintenance, and the very the great features delivered in a very simplistic way, right? This is how it actually looks. This is the view of ArgoCD's applications. So we have two applications here, which are nothing but an entire environment, right, which runs bunch of services. So if you go to one of these applications, you'll see all the resources, right, which would include your services. It would include your deployments of variety of microservice applications. It'll also include all the replica sets and ingress and config maps and variety of other things. So whatever Kubernetes resources you actually need to make your application work on your Kubernetes cluster, those all resources would be managed by ArgoCD, right? And how it's going to be done is what we are going to take a look. So that's about the theory. I just want to get started with the demo now. I just wanted to show you guys exactly how that's all done, right? So we'll just get started with this. So first of all, we'll look at how the setup is done. I hope. Okay. So so that's a ArgoCD. I'm sorry, I just it was my put forward was actually timed out. So I'll have to kill it and I have to forward it again. So my ArgoCD is backed by Ingress, and ArgoCD is exposed by Ingress, and Ingress actually forwards request to it, and that port forwarding was timed out due to some inactivity, and that's the reason why this happened. But anyways, we're back in business. So right here, this is my ArgoCD. By the way, this entire demo you can actually look at right here on my GitHub page. You can go to github.com navico/cube-argocd, right? And I'm going to actually put this in my reference on the slide, which Damien will later on share with everyone. So this is the repository which has everything ready to go. If you follow the instructions and run and run the setup script, it's actually going to bring up ArgoCD for you, which would basically sync up all your Kubernetes resource manifests, which are part of this project, into the Kubernetes cluster, right? So basically, this particular project does several things. The first thing it does is it brings up your local Kubernetes cluster, right, where you're going to run all the demo applications, right? After bringing up that Kubernetes cluster, it's going to actually create the ArgoCD deployment inside it. So ArgoCD will actually come up, and then it'll basically have the ingress setup so that ArgoCD is exposed, and you would be able to access it via localhost. And then the last step is it's going to deploy some test microservices. So I have 4 test microservices here: accounts, admin, customers, users. So those microservices would be compiled, and they would be actually built as a Docker image, and it's going to be deployed in your local Docker registry. So one other thing I forgot to mention is this startup script is also going to actually start local Docker registry for you, right? So you don't need to rely on Docker Hub or GitHub or anything. As long as you have this source code locally, you would be able to actually run the entire demo without having the need of internet or connectivity, right? And that script is basically right here. All you need to do is just run kubeblast with the name of the environment. You can say blue, green, whatever name you want to give to your environment, you can give it, and it'll do all the setup, right? So feel free to play around with this, and if you have any questions later on, let me know. We can always connect on LinkedIn or email, right? So these are apps. All the microservices, they are all Java Spring Boot applications, very thin applications with single endpoint, all of them. And these are all the setup related scripts in which you will find the initial kubeblast, which will set up the entire demo for you. And other thing that you see here is a Docker build, which has a Docker file. So this is actually used to build the Docker image for your services, for your applications, right? And the last thing is the cluster. This cluster has all the manifests, right? If you go inside, ArgoCD itself is deployed as a YAML manifest. So it runs inside your Kubernetes cluster, right? Local Kubernetes cluster. So this is the key YAML file of your ArgoCD. It has so many resources that ArgoCD needs to run under the Kubernetes cluster. So all those resources are under this YAML manifest. And if you go to KubeGrin, you'll see all respective microservice deployment YAMLs, something that we actually looked at in one of the slides, right? So it has the name of your image, and it also basically has how much resources you want to allocate to this a particular deployment. What are your log levels, right? What port you want to run it on, and if there is any volume, persistent volume that you want to attach to it, your readiness and the liveness probes for the stability, high availability, and consistency of your deployment and your pods. And replica is one, and you have also mentioned here the rolling update as your strategy, so that you can accomplish true zero downtime deployment, right? So, and there are a bunch of other things. I'm not going to go in detail, but this is actually how your deployment manifest looks, and it'll be repeated for all the microservices in their respective folders. And this is a service that exposes that specific microservice containers to the world outside, right? So this are all the resources under cluster. All these resources are managed by ArgoCD. So ArgoCD knows this location, and it actually makes sure that these resources are in sync with your Kubernetes cluster. If anything here changes, ArgoCD immediately gets a trigger, and it actually syncs that change to with the Kubernetes cluster, right? And that's what we'll take a look. But this is the overview of my test project. You can take a look, you can explore, and you can play around with it. So let's look at the basic setup of ArgoCD, right? So if you go to the settings in the ArgoCD, you would actually see that there is a option to add repository. So you can add as many repositories as you want. I have added one repository, which is what we just looked at, Kube ArgoCD. So that repository is added, which means ArgoCD now knows this repository is a valid repository. If your repositories are controlled, or if they have access control, user ID, SSH keys, you can basically add those certificates and credentials here, right? You can also add Kubernetes cluster. So Kubernetes cluster is my local Kubernetes cluster. So I have actually added that Kubernetes cluster here as well. And then you can create projects. So I have created a project. So project is nothing but just high level abstraction of related microservices or containers, right? So if I have business related microservices, let's say 10 microservices, right? I would put them all under one project, right? And if I am also running something like Kafka as a stateful container, right? I wouldn't really merge them both under the same project. I would basically put Kafka in its own project, and project is nothing but the high level grouping of alike resources, right? So ArgoCD will let you actually create multiple projects. In the project, all you define is what all what all repositories this project can actually access, right? I've said star, but you can literally change this to whatever you want. So it'll give you all the repositories that you have added, right? So this is how you can actually segregate that Kafka related project is going to access only Kafka repo, and business microservice project is going to access only microservice repo, right? Another thing is, if you have multiple Kubernetes clusters, they'll be all here, right? You can actually select whatever you want this project to target for deployment and sync, right? You can also specify namespace. Namespace in the Kubernetes world is basically nothing but just an environment, right? So you can have multiple namespaces. It's an abstraction or basically grouping of the resources, right, to create a logical environment, right? So you can basically create the project by namespace, so that way that project can only deploy and sync resources in that namespace, right? Becomes easier to maintain and organize. Then you can also have whitelisting of your cluster resources. This is all about the access and granular control. So I can literally say that this particular project should be able to sync only deployment, but should not really change any other networking protocols or rules or any manifest YAMLs, which are kind of risky, right? Which goes across the cluster, and one project changes it would basically impacts everybody. Those resources I can actually exclude from here, right? So whitelisting cluster resources, whitelisting namespace resources, and similarly blacklisting, right? So you can do all of this while defining a project. Once you have a project, you would be able to actually create applications within that project, right? So I can literally go to project, and I can basically create the applications. Or wait a minute, not from there, but from applications. I can go to application, and I can actually create the application and provide the name of the project, which I basically want this application to run under, right? So here is the project, and we'll create the application. We'll create a project, we'll create the application, and we'll basically bring up this entire environment up just in a bit. But I just want to give you guys a basic walkthrough first. So that's about all the resources, repositories, certificates to access your Git repositories and whatnot, right? Clusters in which you want to run or sync your resources, projects, high-level grouping of your Kubernetes resources and applications, and accounts, right? If you actually need some accounts for the access of the cluster resources, you can actually define them here, right? So that's that. Now, if you look at this application, it's a cube green application. If you go inside, you have actually some resources, right? This is a high-level view of these resources. I'm running 4 applications, 4 microservices. Those microservices are part of this particular application. So they are exposed via these services. This is account service, this is admin service, and so on. These services are actually routed by by ingress, right? So I have an ingress setup that basically gives you an ability to access the services via localhost and 8081 port, right? And that basically routes the request to the specific service of your, specific microservice of your choice, right? And these services are exposing the pod of the respective microservice, right? So this is the high level view of what the application really contains, but you have a detailed view as well, where you can actually see much more. You can see all the NFS, like persistent volumes, your namespace, which is right here, your persistent volume, your persistent volume claim. Then it shows you your services. It also shows your service account. It also shows ingress. It also shows all the deployments and whatever else. Everything that is within this cluster folder is all actually going to be here, and ArgoCD is very accurately tracking them, right? So you see all of them here, and what really matters to you is the deployment. Normally, unless you really want to do complex operational stuff related to infrastructure, right? And since ArgoCD is running this, we're able to actually see our microservice dashboard up, right, on my localhost 8080, and that shows 4 services running. And I can actually hit those services by using my Postman. So I'm sending basically just the basic endpoint call. I'm listing all the accounts from the accounts microservice, and it actually lists all the available accounts. I've hard-coded everything just to make things simple and not get into the complexity of databases and whatnot, right? So that's the application, demo application that's running and being tracked by ArgoCD, right? Yes.
We have 2 questions, Himanshu. Yeah, 2 questions. One is from Sriram. He's asking, is kubeapps the namespace?
Is kube admin? Sorry.
Is kube, KUBE-APPS, kubeapps?
No, our namespace is actually kube green, as we can see here. So kube green is a namespace, right? You can see here, and manifest is right there, right? And this manifest is tracked by cluster main kube green YAML, which is right here. So kube green is our namespace here.
Okay, perfect. Then the other one is from Jazir. He's saying, what is the name of the app? I think he's asking the name of the app you are trying to demo.
So it's a kube ArgoCD. You can go to this Navico kube ArgoCD on GitHub, and you'll find this repo. You can clone, and you can just run, like I said, kubeblast. And if you run this kubeblast, it'll tell you, what to pass, right? You need to pass the environment. It'll build everything up for you. However, there is one thing you need to do. If you have a Windows machine, you need to have kind installed. So kind is basically a Kubernetes testing tool. It would let you spin up a complex Kubernetes cluster locally. So you can actually choose to have multiple masters and multiple workers, right? But for demo purpose, definitely we'll have just the one master and one worker, or just one node with master and worker together, right? But kind is the tool that basically gives you ability to create a Kubernetes cluster locally. So if you have Windows, you'll have to install kind. I have some instructions here for installing kind. So you can actually follow those instructions, and then you can literally run a kubeblast, and it'll just spin up the entire demo suite for you. All right, is that it?
Okay, so yeah, he's asking if this is open source. So Jazzy, from what I understand, after the presentation, I'll send a link, and that link will point you to this repo. And on Himanshu's repo, where he's doing the demo from, you have the instructions on how to do everything that he's currently doing for us. All right, yeah. So you should be able to follow up that tutorial later on your own time. And then he's also asking, he said, can I see the number of requests coming to ingress?
Okay.
That's his next question.
Oh, okay. Yeah, you can. You can actually see that. So you need to basically get your either get your hands dirty, or you will have to go to ArgoCD. So let's see. So there is an ingress right there, right? And okay, unfortunately, you have ability to see events and the health of ingress, but logs you can't see from ArgoCD. You have to get your hands dirty and go here, right? So if I go here, kubectl get pods, all namespaces, right? I have this ingress, so I should be able to actually go here and literally say logs -- follow and -- namespace equals. So this logs will go on. So you can go and check all your pods and just do kubectl logs for that pod, and you'll be able to see the logs. And that's not how normally things done. This is just the demo project. That's the reason you have to get your hands dirty. But in a real world, if you use Kubernetes, you'll have something like a fluentd that will collect logs from all the pods. So you'll run fluentd alongside your containers on the same Kubernetes cluster. It'll collect Kubernetes system logs and your application logs and ship them to your logging database like Elasticsearch. And with Kibana, you can actually visualize them, right? But yeah, you can access ingress logs even without having any of those. All right.
Right, Hima. So the visualization we see, is that created by ArgoCD dashboard?
This.
No, there was the visualization of your application, the one that shows the ingress with all the traffic going to the microservices.
Oh, okay. So we're talking about this one, right?
No, maybe click on one of those. Let's see.
Oh, okay. I see. So if you go to accounts, right, and go to logs. So this is your business application.
Yeah, no, not this one. The one I've seen it a couple of times that you show your application where the ingress comes in, and then the traffic, you see the traffic going towards the microservices.
Oh, right.
I think you probably need, that one there. Is that done by ArgoCD?
Out of box from ArgoCD.
Okay.
Right.
Okay.
So basically, I mean, it's brilliant. ArgoCD knows that how things are actually connected, and logically, if you would think, I mean, it's possible, right? Because that's how your manifests are. You have a deployment. So if you can actually go back here, right? I would show you one thing, right? So if you go back here, setup, cluster, kube, accounts, deployment. So you know that your container port is 8080, right? Now, this is your deployment. So when you run this deployment, it's going to actually spin up one replica, one pod of this image, right here. Accounts 11113 from localhost registry, right? It's going to run one instance of that, right, on port 8080, and that we are exposing via account service. So 8080 is a target port, and the service is basically exposed on 8080 port, right? So there is a link between a service and the deployment, right? And if you look at ingress, right, ingress has actually all the routes. So this is my ingress. What it shows us, it actually shows that admin is on port 8080, customers is on 8080, and so on, right? So these are my routes, right? However many microservices or applications I have, I can actually put them all here. I can create complex paths also. If I have a dedicated IP, I can set that DNS or dedicated IP also. So instead of having local host, I'll have something that's publicly available, right? So all of this are basically connecting, all the resources with each other. And that's what ArgoCD is actually doing. It knows that Ingress has defined the routes for accounts, admin, customers, users, and those services are the ones Ingress knows, right? So if someone accesses Ingress URL 8080, localhost 8080 with Cube accounts, Ingress knows where to actually send it. So it'll send it to accounts. Instead of this, if I send it to customers, it's going to basically send it to customer service, right? So that's the logical relationship view that ArgoCD, pulls out for you, right? And the services are forwarding to ultimate pods, which are running your applications.
Okay.
Does that make sense?
And yeah, sure. And this microservices is your own application?
Yeah, they are the test applications I've written. So if you look at them, right? I mean, I'll go to IntelliJ, much better. So basically, I have. Let me close this all just to make it clear and easy. So I have apps, right? So this is my Git repo. So I have apps. This is account apps, which is built using Spring Boot Gradle, right? So there is a build.gradle. There is a source code which has, just one REST controller, and inside that I'm actually hard coding my data. So if someone calls my endpoint with the Cube's accounts a path, then I'm going to return all of it. If someone is calling with any number, I'm going to return just this, right? So this is like very tiny little microservice for the POC, right? And there are corresponding resources like application YAML file, right? Which makes this application microservices registered into admin console, right? So this is Spring Boot admin console, which basically provides you the service registry and service location and registry service, right? So things related to that, configuration related to that is here, right? And you have Bootstrap for log path and log back Spring XML for the logging configuration. So yeah, those are the applications inside the Cube ArgoCD project that I have.
Okay, perfect. There are a few questions, but if you want to continue and answer those later, that's fine as well.
Okay, yeah, I think we can do that. So so basically, this is ArgoCD. You would be able to actually see all your resources right here visually, and you would be able to see certain things. The first thing that really matters to you is the state healthy. State healthy means the application as a whole is very happy and healthy. All the resources inside are all green hearts, right? Happy hearts. That's what this means. If one of these pods would have been down, or if some service wouldn't have had any issues, or Ingress or any other resource would have been missing or not properly deployed, this would have been broken red hard, right? So that's the first thing. The second thing is synced, which means the whatever you have on your Git repo right here inside your cluster path is all up to date on your Kubernetes cluster, right? That is what it means. And here is actually the commit of your Git, right? So it shows you that this particular is the state of your application, which is in sync with your manifests residing on your Git repo, right? And last sync was okay. There was no error, right? So these are the basic indicators that helps you identify how exactly your application sync is going and what is the state of your environment, right? So now if you want to actually try a few things, let's try, right? So first thing, I'll just go back to my presentation once and show you guys a few things. Sorry. So let's see continuous delivery manifest sync between Git repo and Kubernetes cluster. Okay, so what that means is if I make any change on my manifest, right, that change would actually propagate to Kubernetes cluster immediately by ArgoCD. So ArgoCD has a webhook that periodically keeps on delivering triggers or changes to ArgoCD, right? So that period is about 5 minutes. We're not going to wait for 5 minutes. I'm going to manually hit refresh, which will basically force ArgoCD to go to Git repo and get the updates, right? So let's make few updates first, right? So I'm going to open up my cluster. So we're going inside the manifests. Remember, the manifests are the ones tracked by ArgoCD. So I'm going inside my manifests of accounts, deployment, and the easiest thing I'm going to do is replicas change to 3. Make sense? So the only change, as you can see here, is accounts deployment, replicas 3. Right? So we're basically changing the replicas from 1 to 3. The moment I check in this file and ArgoCD picks up that change, it is immediately going to spin up 2 new instances of account. Right now, account service has only 1 instance, as we can see here, right? And inside applications also, you see just the 1, right? So let's make this change very quickly. I'm going to actually commit this. So git add, I have a few other dirty changes. I'm not going to worry about them. The only one that I care is accounts deployment YAML, right? Git commit. Let's put a message that makes sense. Changed replicas to 3 for accounts and git push. So I push this. Now, if we go and take a look here, we should be able to actually see inside our cluster accounts and deployment should definitely have number 3, which is right here. ArgoCD should actually pick it up in 5 minutes, but let's not wait in the interest of time. I refreshed, immediately it showed out of sync, right? It's actually going to sync it, and when it actually syncs it, it's going to give you 3 instances. These are all the events. Wow. Okay, just a second. So I've actually deleted accounts. Normally, I mean, this works very consistently, but it seems like there is a state corruption right here. If this would have, flied nicely, it would have just worked without any problems, right? So let me do one thing, new app, right? And with this, we will actually, see our application creation also. I had been playing around with this earlier today. Probably it has broken it, right? So I'm creating an app. This time we're going to name it just kubeg, right? Sync policy, whether we want automatically, whether we want ArgoCD to automatically sync the changes or we want to actually manually do it, we can specify with this, right? I'll say self-fill and prune resources, which are like, invalid and not used anymore. The repositories, I'm going to use this. A revision is actually master branch. Okay. And then I'm going to provide the path as cluster, right? Let me just make sure that that's a right path. Scripts, ArgoCD, Argo Blast. My path is setup cluster. Yeah, I knew that. Okay, so it's setup cluster cube green. Okay, and my cluster is actually this. My namespace is going to be cube green, and my directory, I want recurse, so that inside the cluster folder, it's going to create resources for all the directories. And that's pretty much it. And with this, I just want to delete this app. So this is the new app that I did. And as you can see, I mean, I don't know what happened with that particular app. Like I said, I had been doing a lot of bleeding edge stuff for other experiments. And that made, I mean, that basically had some, wrong commit on that Argo application. And that's the reason why it failed. But now we're talking to master branch of this repo. And Argo knows that. And that's the reason why it immediately started 3 accounts, as you can see. And once they are up, you'll be able to actually see them here. And let's try that, one more time. So it takes us a little bit, for the applications to come up, but they will, once they are up, they will basically show us all 3 instances, right? So I see the notification started popping up, and very soon we'll actually see multiple instances here. Well, anyways, that Spring Boot admin at times take a little while for instances to show up. But the fact is we have 3 pods, and we can take a look on the back and just make sure that we do. Okay, well, we don't need to go back. I think they are all here. You see 3 instances actually came up here. And that's that's what ArgoCD actually did for us. Just to make it kind of repeatable process, let's just convert those 3 into now 2. Okay, so it's immediately going to kill 1, right? So git add this, git commit -m reduced to 2, push. So once this is done, now we should be able to actually refresh Argo, and immediately it's going to show sync. So this is the right thing you want to see. You want to see that blue color syncing, and you should be able to see your message here, the name of the author, and synced. And immediately ArgoCD actually taking 1 pod down, terminating. So at the end, only 2 will remain. So this change that we have made is instantly reflected into your Kubernetes cluster, right? So ArgoCD makes sure that the application that you have created, right, and whatever that folder within the repo you have specified, all the manifests are in sync with your Kubernetes resources or not. If they are not, it will immediately sync them, right? So that's the continuous delivery that it actually provides you. So logically, the only thing you need to do is you need to actually make changes to your manifests, right? So here, instead of this, if I just literally change the account's version to 112_14, right, and check this in, immediately ArgoCD is going to deploy the new version of your image, right? So that's a thing. And we can do one other thing. Let's change the image very quickly, right? So I'm going to change the image to so I have my Docker Hub account where I have the accounts image as well. right? So I'm changing it now, right? So I'm changing the image to a different image, and let's put this. So this is what normally we do in our Kubernetes deployments or releases, right? Nothing really changes. The only thing changes is the image tag, because you have a newer version of your code changes, right? So I've changed that from basically localhost image to the one on the Docker Hub, right? So if I go ahead and push that, add commit Docker Hub image and push. Perfect. So once that's done, before that happens, let's go ahead and verify one thing very quickly before ArgoCD actually syncs that. We'll go to accounts deployment and we'll make sure that our image actually shows up as the local host right there. So the current deployment has the localhost 11113, but the one we have actually changed to is Navico accounts, right? So we'll sync this, and ArgoCD is immediately going to pick up the change. And what it's going to do now is not going to terminate all the instances, right? So this basically demonstrates the second aspect I wanted to demonstrate, which is rolling update, right? And most of these concepts, we have been through in previous sessions from Damien. He has showed us all of this via command line, which is more hands-on, right? And this is kind of like all via ArgoCD. That's the only difference, right? But as you can see, the rollout was not really enforced any outage, right? The old pod is still running until ArgoCD actually brings up the new one, and liveness and readiness probes are succeeded, right? ArgoCD is not going to terminate the old pods, right? So while the deployment is going on, ArgoCD is doing the sync, right? If you would have kept on hitting your endpoints, you would have consistently gotten results, right? On customers, let's see accounts, right? You would have consistently getting these results, because the deployment that you're doing is your zero downtime deployment. And now if you look at this, your image is Navico Cube accounts, right? So you basically upgraded your microservice code, right? Without any outage, right? I mean, that's great feature. Definitely it's a Kubernetes a thing, but ArgoCD provides a very easy mechanism to accomplish that, right? And one other thing that I wanted to actually show you was this zero downtime guarantee you got because of this strategy rolling update, right? So I have actually defined the strategy as a rolling update, where my max surge is 1 and max unavailable is 0, which means I don't have any tolerance to accept unavailability of this service, right? So maximum number of unavailable instances would be 0. So it has to be always up, right? So this is what is actually giving us that zero downtime guarantee. Next thing, desired state management. We kind of covered this by changing the replicas from 3 to 2, 2 to 3, and then back to 1, and it immediately made those changes, right? So right now we're running replica 1, right, and it's actually running for us 1 accounts, right? So that's something we covered. We can delete deployment, right? So if you want to delete the deployment altogether, you can actually do it, right? You would be able to do it right here. So let's go ahead and try that, right? So this is our deployment. I can literally go here and delete it. I can say force delete. That's going to make my account unavailable very briefly for a second. But ArgoCD knows that it needs to honor the manifest sitting in the GitHub, right, in my repository, and that manifest hasn't changed. So immediately it's going to actually spin up the same deployment, right? And that's what it has done now. You killed that deployment. It's like pod got crashed on Kubernetes cluster for one or the other reasons, but ArgoCD will bring it up, right? So your accounts is up now. So you're not going to be able to actually see your desired state compromised, right? If you really want to kill accounts, the only option that you have is this. You basically go here and just literally make this replicas to 0, right? Once you make that replica as 0, you would be able to actually see ArgoCD safely taking that that deployment down, right? So I added that change. Let's commit it. Remove account, push. So once that is done, we can refresh this. As soon as we refresh it, ArgoCD knows what to do with it, and it's actually going to terminate. Account's going to now vanish for once and for all, right? So this is basically desired state management that is actually provided. And remember, you only got rid of the deployment. Your service still exists, right? So that's the reason why this service is still hanging there, but account itself is going to be disappeared, right? So that's basically desired state management and deleting your deployment. That's how you can actually delete. There are a variety of other features on ArgoCD. You can go to any specific pod and you can actually tail the logs right here, right? The logs will basically move for you. And you'll be able to see them. If there are events, you'll be able to actually see those events. And those events are nothing but kubectl get events for a specific resource. And whatever that you get on command line, you'll actually see it here, right? So that's possible. One other thing that you can actually do is by going to individual resource, right? And making the changes on the fly. So I can literally go here and I can actually make the changes right here and save it. It won't work because we have actually chosen automated sync for this particular application. If we would have actually not chosen this sync automatic, where is that? Sync options. So sync options are, so this sync is automated. I don't know why it's not showing it here, but the sync is automated. That's the reason, we are seeing everything's basically syncing as soon as you push to Git, right? But since the sync is automated, you would not be able to actually temper the resources from the UI, right? So if I want to go to, let's say admin, and if I want to make any changes, I won't be able to actually make any changes here, but otherwise I would be able to actually go and change the live manifest, and I can actually change number of replicas to 3. I can save. For a single second, you'll feel that ArgoCD caught this and it's actually going to honor 3, but it would not, because it knows that this application is set up as an automated sync policy. So all it needs to care about is what is there in your Git repo. But if that sync would have been manual, then you would have had a control of changing your manifests right out from your ArgoCD, right? Which is not good because those changes are going to be lost once you kill that deployment or resource. Those changes are gone. But if you put them in Git, you have them persisted. So you can basically bring them up in the same fashion with the same state, right? That is the advantage. So that's one of the features that you can actually consider using if you're doing a manual sync. And Then other thing is history and rollback. So this basically gives you all this gives you basically all the states of your application resource changes, right? That ArgoCD has picked up from your Git as and when they were pushed or committed and deployed to your Kubernetes cluster. So it shows all of them, right? And you can go to any one of them and literally say that deploy this for me, right? I mean, I'm sorry, not deploy, but roll it back, right? So imagine in a traditional environment, right? If you want to roll back something, it's a big hassle, right? It's pretty manual, fragile process, and it requires touching so many things, right? To be able to even roll back to previous known and stable state, right? But here it's so simple. You can literally go to that particular state and say, okay, right? However, since you have sync, manual ArgoCD, well, I mean, it basically did that. So, I thought, since the sync is automated, probably rollback also won't come under that state. But it seems like, it did, right? So, anyways, I mean, that's a rollback which is kind of very easy and simple to accomplish if you want to. And other thing is actually looking at the application difference, right? So it now shows you that what you have on the Git is basically 0, and what you have actually changed here in the context of your ArgoCD UI is 2, and that's not there on your Git repo. Just because we rolled back, right? It rolled it back and got you down to 2, right? And that's the reason why you got 2 instances, up and running for accounts, right? But actual manifest on Git still has replica 0, and that's indicated by this out of sync, right? So what it shows is the sync status, which is basically the app difference, which is which is right there, and that's the reason why your overall status shows that it's out of sync, right? So this is, I think that's all I really wanted to talk about and walk you guys through, right? You can look at this Git repo, this Git project, and you can try it out and let me know if you guys have anything. I would stop sharing my screen, and we can open up for questions if there are any.
All right, thanks so much, Himansu, for the presentation. I think everyone will find that really useful. So yeah, there are a couple of questions. So let's take it from where we stopped before. All right, so Sriram said, is FluentD deployed using CRD, that is custom resource definition?
That's right. Yeah. I mean, FluentD's container images are already available on Docker Hub, right? And that will be like a normal deployment, not CRD. So a custom resource definition you basically need to do when you're creating something different, right? Not pod, not deployment, not namespace, but you want something totally custom. So it becomes kind of a kind, right? And that is called, that is basically CRD. So for deploying FluentD, you don't need to define CRD. You just need to find FluentD image from Docker Hub and put that in a Kubernetes deployment manifest and run it on your Kubernetes cluster. So you could literally create one other YAML file for FluentD deployment and put that Docker Hub FluentD image and put it under that cluster folder. If we talk about this demo project, and ArgoCD will basically start FluentD there.
Mm-hmm. And also, generally, I would say the way you deploy applications in your cluster could depend on how you are managing it. For example, if you're using Helm, you can use Helm to deploy anything, including FluentD. Yep. Or if you're using Kubernetes operators, you can also use the operators to deploy FluentD. or you can use YAML file like Himanshu said. So a lot of time that will depend on how you're actually managing your cluster environment for Kubernetes.
Yeah.
And then he said, what Kubernetes version is this app deployed on? So which Kubernetes version are you using?
Oh yeah. So we can basically check kubectl -- version.
Yeah, current version is around 1.9. So if you're using the latest, most likely it's going to be around 1.9 or 1.8.
Yeah, that is right. It's 1.8.
Okay, you said is ArgoCD, is it reading YAML file? Is ArgoCD reading YAML file?
Yeah. So ArgoCD itself is a deployment, and it basically runs as just like any other resource on a Kubernetes cluster, right? So Kubernetes cluster is basically very it's basically inclusive of everything that you would need to run as containers, right? So even the tools which are managing your logging, which are managing your deployments, which are managing your building, right, messaging, all of them can basically be running on the same Kubernetes cluster, and they can basically help out each other. Like ArgoCD running on the same Kubernetes cluster helps you track and manage your deployments in the same cluster, right? So if you go to ArgoCD's website, you would be able to actually find instructions as to how to run it within your Kubernetes cluster. They have the YAMLs and everything. That's where I got it from, and I did a very little modification for my own purpose, and then I basically created that on my Kubernetes cluster, and that's what we looked at today.
All right, thank you. The next question is said, what should we do when we have increased traffic only for account services beside replicas, and it is impacting customers, admin, and users' services?
Okay. Can you repeat the question again, Damien? I'm sorry.
Yeah, I think what he's trying to say is that he said when we have increased traffic only for account services,
right,
besides replicas. If you want, I can make it public. Let me make it show. See if you see it.
Oh,
can you see it?
Yeah, I can see it now. right, I see it now.
Okay.
Thank you. Yeah, so I think definitely replicas is one thing to handle the parallel processing or increasing your throughput, but there are other things also, such as resources, right? If your applications requiring more resources in terms of CPU memory, those also you can change, right? And that would basically give your application more room and resources to do work more efficiently, fast, and in parallel. So I think those are the two standard things: the replicas and the CPU memory resources. You think of anything else, Damien?
Well, I wanted to add as well. So if you have a cluster and you have enough resources in your cluster, so then one service shouldn't affect other services. However, if that is a concern, you can give a quota. You can give a quota for one service so that that service doesn't consume so much resources.
Right.
So, for example, you can say don't consume more than 2 GB of RAM, and if that is the maximum being consumed, then Kubernetes will no longer allow you to use more than that.
Yeah, okay? Yeah, that is true. There is always a ceiling. That's right. So basically, those resources, like Damien mentioned, you can define the quota. So the applications don't really take more than that. And also, if you don't define quota, there is a basic resource limits and request that you can set for every deployment. So what that means is, whatever is that limit that you have set for memory and CPU, that's the most that the Kubernetes is going to give to that deployment, right? More than that, if that application needs, it's not going to be available, and then it won't really impact other services.
Okay, thank you. That's the next one.
I think that's a very good question, and even I'm kind of curious. I haven't really seen any specific pattern. At times, it actually kills the one that's least used. At times, it kills the one that is oldest. Newest, right? But I don't know. I think need to read through to see if there is any specific pattern it follows. But
Yeah.
if you have deployment which is stateless, it doesn't matter which one it kills, because they are all guaranteed producing same results, and they all have exact same healthy state.
Yeah.
So
these are stateless services, so it doesn't matter. I think it's more random. Like you said, it's stateless. It doesn't matter which goes down or up. If it were a stateful application, then that will matter.
Right.
But stateless usually it's just random.
Yeah.
The unlucky one get killed.
Right. Yep.
Yeah.
Right.
Okay. Let's see. Few more. All right. What was used to build a Java wrap? I heard Tekton.
So Tekton, I knew that I would not be able to fit in this session because Tekton is a different world altogether. So I have a different demo for it. Maybe one of the future sessions will cover that. But Gradle is what building the Java code. Right. So I used Gradle. So on the demo project, if you go and see, there is a build.gradle for every application, right? And that wouldn't change. If you have Tekton, Tekton is also going to use some internal build tool like Maven or Gradle, right? The help that Tekton really gives you is whenever your code is changed on the repo, immediately Tekton job will basically trigger with the webhook, and it'll actually build your code using Gradle or Maven, whatever you have chosen, and then it would create the image and publish to Nexus. I mean, whatever your artifact is, right? So this applications do use Gradle, and Tekton is not part of this demo.
All right, I can answer this one briefly. Can you explain about daemon sets? So daemon sets are kind of similar to deployment objects. The main differences between them is that for daemon sets, you have to tell them how to run. For example, you can say you want them to run on every node. So when you create 5 replicas, those 5 replicas are going to be distributed on every node. But you can also make daemon set to work on nodes based on labels. So for example, if you have certain nodes you label SSD or production, and you want that daemon set to run only on production or on nodes labeled SSD, those are the only nodes that daemon set will run. But with deployment objects, you don't have any control on where the replicas run. That is just controlled by the deployment object. You can decide to send them to 2 nodes or 3 nodes or whatever the case might be. But daemon set will make sure that there is a copy on every one on every node of your cluster. So if you have 5-node cluster and you run a daemon set, there will be 5 replicas, 1 on every node. Okay, I hope if you want to add anything, you can add to that.
No, I think that makes sense. Absolutely, it's good.
Okay. All right, then let's see, what does it share? All right, let's see this one. And then would that not be in the logs?
Yeah. So I think that's a basic status of the deployment, right? So you can, I mean, if you have mentioned something wrong in your deployment manifest, right, like wrong image which is not available, then the status of that deployment will become image pool error, right? If Kubernetes does not really have enough memory resources and you're trying to spin up a deployment, you may actually see out of memory as a status. Similarly, when there is an application level problem, the image that you have built is not starting your application process nicely, it would be a crash back off loop error. So on the deployment, you'll see crash back off loop. And what Kubernetes internally thinks about that status is, there is a chance of recovering that deployment. So it keeps on retrying, right? It keeps on retrying every few minutes until it gets fixed.
All right, perfect. I think that is the last question. If you have more questions, feel free to email them to us. If you send them to me, I'll send to him. If you send them to both of us, that's perfect as well. And so someone was asking if we're still going to have another presentation on DevSecOps, and I said no more for today because we're out of time already. So based on the questions we have, there's no more. Himanshu, do you still want to add anything, or should we round up?
No, I think thank you everyone for joining, and thanks Damien for hosting such a wonderful event. I hope everything we get over everything and just start meeting again, personally. Those were
absolutely.
Yep.
Yeah, thanks for the presentation, Himanshu. Very informative. So we'll send out the link, and then feel free to go ahead and deploy your cluster, and then play with ArgoCD, which is trending. It's really trending. It's becoming really popular.
Yeah.
All right. So I think that'll be it for today. Thank all of you for joining us. And the next meetup is going to be on November 18th. And as usual, we'll schedule something and then publish it for you to get all the information that you need. All right. Thank you very much, and good night.
Thank you.